Perhaps the most notable thing about this question initially is that it states that particle number 2 always stays directly above particle number 1. So let's keep that idea in mind and kind of scoot down here and take a more careful look at what's going on. So we know that particle 1 is launched with a velocity of 10 meters per second horizontally to the right, and it just kind of moves along with that constant velocity. So once particle 2, the green one, reaches its maximum height, particle 1 is still moving along at a velocity of 10 meters per second to the right. Now, the only way that particle number 2 can stay directly above particle 1 the whole time is if its velocity in the x direction at that maximum height is also 10 meters per second. In fact, the velocity in the x direction for particle 2 will always be 10 meters per second so that it can stay directly above particle number 1. Now, the question is conceptually trying to encourage us to think of these two particles as a single particle with a location at the center of mass of the two individual particles. So, in other words, you can kind of imagine a single particle that's moving along in a trajectory like something of this nature, and that is what we're trying to kind of conceptualize here, that the two particles can be combined into a single particle. Now, for us to proceed in answering part A, which asks us what is the maximum height reached by the center of mass of the two-particle system. So we're actually going to be looking for this maximum height right here. But in order to do that, we have to find the maximum height achieved by particle number 2 first. So how do we achieve the maximum height of particle number 2? Well, there's a couple of different ways, but one way would be to conserve energy. So let's focus our attention on particle number 2, and we'll call this location its initial position, and then that maximum height will be its final position, and we're going to conserve energy. So take a look at the initial position, and particle 2 is launched at ground level. And so the only energy that's present initially for particle 2 is the kinetic energy. So we would have 1/2 times the mass of particle 2 times the velocity of particle 2 squared. In the final position, there are two forms of energy. There is the kinetic energy, because particle 2 is still moving. We have therefore 1/2 times the mass of particle 2 times its velocity x component squared. Notice that when the particle 2 gets to that maximum height, there is no y component of its velocity. It's not moving up or down in that moment. It's only moving to the right. And therefore, we only need to plug in the x component of its velocity. So be careful there. And then you're going to add the gravitational potential energy, because particle 2 is now located above the surface of the ground. So you'll have the mass of particle 2 times g, and then times that maximum height. Now, what's nice about this setup is that the mass of particle 2 is present in every term, and therefore it would divide out, leaving us with this equation. Now we can begin to plug in known values. We know that initially the velocity of particle 2 was the 20 meters per second. On the other side, the final velocity was the 10 meters per second. We know g is 9.8, and then we're going to solve for that maximum height of particle 2. Simplifying the right-hand side, the left-hand side would give us 200. Now on the right-hand side, we have 50 for that first term. Now what we'll do is subtract the 50 from both sides of the equation, and then we'll divide by 9.8. And when we do all of that, we can see that the maximum height of particle 2 is about 15.31 meters. Now that's not our answer, because we didn't want the maximum height of particle 2. We wanted the maximum height of the center of mass of this two-particle system. So let's think about that. We have particle 2 here, and then right beneath it at ground level is particle number 1. And they're both moving along to the right. And we're looking for the maximum height of the center of mass. So that height right there, maybe we'll just kind of call that y, center of mass. Now, we learned in this chapter that the center of mass of a y-coordinate would equal 1 over the total mass multiplied by the summation of each particle's mass times its y-coordinate. That's an interesting looking equation, but let's go back and get the total mass. We know that the mass of particle 1 was 5 grams, and the mass of particle 2 was 3 grams, so the total mass there, of course, is going to be 8 grams. So we can fill in 1 over 8 grams, and then multiplied by the following. So we can start with particle number 1, which is the red particle. And again, that mass is 5 grams. So what you'll do is multiply the mass of particle 1, 5 grams, times its y-coordinate. But look, particle 1 is at the ground level, so the y-coordinate there is just 0. And then you go on to particle number 2, whose mass was 3 grams. And now look, the y-coordinate of particle number 2 is that maximum height that we had just found. It was that 15.31 meters. So we'll fill that in. And now we're going to be able to solve for the y-coordinate of the center of mass. So we pick up our calculators. This term goes to 0. So you're just basically doing 1/8 times, and then in parentheses you have 3 times 15.31. And when you work that out, you will see that the y-coordinate of the center of mass of this 2-particle system is about 5.74 meters. And so that is the correct answer to part A of the question. We move on to part B, which asks, in unit vector notation, what are the velocity, and then later we'll do the acceleration of the center of mass. So we need the velocity of the center of mass. So that center of mass is located right here, and it's moving along. And this is interesting, actually, because particle number 1's velocity was that 10 meters per second, and it was going to the right. Particle number 2's velocity was the same. Remember, at the maximum height, it too was just moving along horizontally at 10 meters per second. So there's really no calculation to be done here. This is just a conceptual point that for the center of mass, that is also moving at 10 meters per second. There is no y velocity at all for the center of mass when it achieves its maximum height. So we can say that the answer to part B in this sort of unit vector notation, it only has an x component. So it's going to have a velocity of 10 meters per second. And then that x component is symbolized by I hat. So there's the unit vector notation answer for part B. And now for part C, the acceleration of the center of mass. And we're going to be able to do a similar calculation to what we did in part A. We're going to do 1 over the total mass, which you will remember was 8 grams. And then in the parentheses, what we'll do is just take the acceleration of each particle and kind of multiply it by its mass. So for example, if we look at particle number 1, whose mass was 5 grams, we would take that mass of 5 grams and multiply it by its acceleration. But now wait a minute, particle 1 was simply moving at a constant velocity in the horizontal direction. It doesn't have any acceleration. So that acceleration would be 0 meters per second squared. And then we move to particle 2. We're going to add this, whose mass was 3 grams. And now ask yourself, well, what's the acceleration of particle 2? And the answer, of course, is that particle 2 is in free fall. So the acceleration is the acceleration due to gravity. It's negative 9.8 meters per second squared. Now keep in mind the direction there. That's downward. So that's going to be in the y direction. We'll keep that in mind when we process this calculation and put it in unit vector notation. But moving on, we're going to basically just have 1 over 8 grams. That term in red is going to cancel because 5 times 0 is 0. And then you're just going to be multiplying by the 3 grams times the negative 9.8 meters per second squared. The grams will end up canceling, so you'll have a unit of meters per second squared. And when we process this calculation, we're going to get about negative 3.68. So the acceleration of the center of mass will be as follows. Remember, that negative 3.68 meters per second squared was in the y direction. So in unit vector notation, you would attach a j hat to that. And that would be it. The x and z would be 0. So this is the final answer. If your homework system actually wants you to input the x and z directions, you would just say 0 for the I hat and then 0 for the k hat. And so there is the final answer to part C. Thanks for taking the time to watch the video. If you're interested in making a small donation to my cause, I'd greatly appreciate it. But of course, please don't feel obligated to do so.